I've got one of the older ones, which allows me to do it this way. Thank you, Mariah, for helping him out with that. Much appreciated. Okay, so anyway, how do I put a space? I want to put the 2 right there, and I don't want to type everything else again. Anybody know this trick?
Second insert.
Second insert. Second insert, or second delete, actually. You press second delete, which is right next to mode. Now you can just type the number 2 and it'll shove everything over. Shoves everything over. If that doesn't work, just type it again. It won't take you more than a couple seconds, but... Yes, we now have to divide by 0.1. Yes? Average rate of change in distance over change in time. No crap. Just erased everything. I'll just do it again. This is another reason it's having in there is nice. I hit a stupid button accidentally, cleared the whole thing out, and go back and fix it. 10.2 divided by 0.1. I get 36.6 feet per second. Feet per second. So what's happening? It's getting faster. It's not getting faster quickly, but it is getting faster, and it should be getting faster because I'm creeping up on that point. I'm creeping up. We can't ever get to the point, but we can get damn close to it. That's what I want to get damn close to it. So I think I had to do 2 more, yes? 100th of a second and 1,000th of a second. And I think this is where this really comes in handy, and you start getting nonsensical results if you don't do it this way. This is what, okay, so we'll come back. We'll do it this way first, then we'll go back and see what breaks down if you don't do it this way. If you try to do it the way we did, no, don't do that.
No, now I like this one.
Oh, good.
All upset.
See, Carrie, and I can't explain the melt. I must have said something wrong on Wednesday to make you guys hate this. This is pure beauty. Please, Faith.
Oh no, I went back through yesterday and watched the YouTube.
Yes.
Do it from Wednesday.
Yes.
So much more
Oh God.
like,
Okay, so it was just the end of April. Tax day read.
But I had to hit pause a couple of times.
Hey, that's okay. That's okay. You guys have to understand what you're doing right now. You're doing calculus right now. You're doing Math 251 right now. I mean, that's pretty freaking rad. I went back to the department and bragged to my department about you guys on Wednesday. I was like, guess what 105 did today? 251. You are doing what's called a limit as h goes to 0 of a difference quotient. Now, you could also just call it your spinometer, because that's what it is in this case. So you're doing calculus, so I like slowing it down, Faith. Yeah, I like taking it slow. I love the fact that the video's there and you can pause it, watch it again, That's fantastic. Good, let's keep going. So now we're at 100th of a second, yes? So, 10.3 is okay. 10.2 is going to have to be 10.29, yes? 10.29. I'm going to insert a 9 right there. And this is going to be 0.01, 100th of a second. Yes, 100th of a second, 0.01. See how fast I'm going? 36.8 feet per second is what I'm getting. 36.8 per second. Happy? Happy there? Let's do the 1,000. And then I want to make sure you understand the difference is in 200 versus 200.33. That's the only difference. Some of you guys are getting different numbers now. You might notice that if you did this in class very quickly on Wednesday and you got it turned in right before you left, which was great, way to go. The problem is, if you do that and you're using that 200, some of your speeds may have started going back down. Right, and that's the problem because think about it. In 1,000th of a second, how much distance am I covering? Well, I don't know. I don't know. Let's figure it out. So second enter, let's go down to 1,000th of a second, which is a split second, right before I cross that line. So 10.3 to 10.2, 9. 9. One more 9 at the end there, yes? And thank you, and then one more 0. Michelle, thank you, and then one more 0. Now, real quick, before you guys go ahead and hit enter. That's totally fine. Go ahead and hit enter. I'm going to take out the 001 just for a second. That's how far I traveled in 1,000th of a second. You see, that's a tiny distance, 0.03 feet. 0.03 feet, yes? That's where the extra 0.33 feet is going to make a difference because that's now significant. It's 10 times bigger than that, yes? It's 10 times bigger than that. And that's why I think things were going wrong in those calculations. I think. Don't worry about it. Now we do it with the machine. Let the machine do it for us. Divided by 0.001. Whoops. 36.8.
Again.
Again, well, but check it out, Tammy. Thank you for that. But check it out. Look, it actually is a smidge faster, isn't it? And guess what's going to happen if I go to 10,000th of a second before, and 100,000th of a second? I'll do it. You know, it's not on the quiz. I'll do it anyway. Right?
You're having too much fun.
This is freaking awesome. This is what the cops are doing with the radar gun. When they are pointing that gun at you, this is what the gun is doing. This is what you can take to court and contest. When's the last time it was calibrated? You see how being off by 4 inches makes a huge difference in your speed?
Yeah.
If you think you weren't speeding, the radar gun might be miscalibrated. This is an argument. You've got the math argument now. I'm not saying contest the cops at every turn, but I'm saying if you think you weren't speeding, this is a mathematical argument for it. Okay, here we go. Whoops. There. 36.79. Now look. 36.79. 79. See? See? It went up again. It went up again. A smidge. Only a smidge. We can go out to one more decimal place, and then I'll stop because it's getting ridiculous.
I'm thinking the next one, the 6 will be a 7.
There we go. Oops, I forgot to put the 9 in there, didn't I? Yeah. 5.7, 5.6. It was right. So the thing is, we can get infinitely close to that second point. We're never going to get to it. If you get to it, you get an error because you have 0 divided by 0, and that does it. But that's what Math 251 seeks to rectify, is dealing with this. But at this point, this is where I say, we're close enough. Because the next question on the quiz says, how different were the last 3 calculations that you did? Totally? Or not really, actually?
Not really.
Not really, actually. That's the whole point. That's the whole point, is that they're essentially the same. Which means, if you're looking at this curve, what we did starting on Wednesday, try to drink in what we did starting on Wednesday. We started by doing my average rate of change for the whole trip, which was 13.3, well, you had it, 13.3 feet per second, I think is what it was, thanks, sir. 13.3 feet, or miles per hour. Miles per hour, 13.3 miles per hour. We're going to convert this for momentarily, too. Then I said, yeah, but that's not how fast I'm going at the end when I cross that last marker. So then we did this one, from halfway to the end. And I got going faster, yes? And then the quiz took over. And the quiz said, yes, but how about from here? And how about from here? And how about from here? And all of those calculations, that's what you guys just did. And all those calculations were great. But all of them are still what are called secant lines, which means it's a point to a point. What you just did with the last couple of calculations was you shoved the points so close together, they're essentially indecipherable from each other, which means you've got what's called a tangent line, which doesn't hit the curve in 2 points, but instead hits it in only 1. And that is what your speedometer is reading back to you when you're driving down the road. When you're driving down the road and the speedometer says you're going 25, it means right then at that moment, not from that moment 5 seconds down the road, right then at that moment. Now the way the speedometer is not doing calculus. Anybody know how the speedometer works in your car?
Hit the gas pedal and go forward.
Well, that's how the car goes forward. How does the speedometer work in your car? Does anybody have a speedometer that because they messed with the recommended tire size in your car, it does not work right anymore? A couple of you, yes.
Oh, yeah.
I had a girlfriend back in high school, kept getting busted for speeding. She's like, my speedometer says I'm going 55. I'm like, yes, but you're going 62. Because you put huge tires on your Camaro. Yes, I'm from the East Coast, thank you. So the problem is, the speedometer predicts a certain wheel size. Do you guys want a quiz on this?
No.
Yeah.
No.
Okay, I'll just tell you that. Yes?
Maybe that will help us.
Let me give you the overview. And then I'll put a quiz up for the next couple weeks if you want to do a quiz. You can always ignore it, right? And that's the point. So the idea is, a wheel has a certain size, diameter. Say it's, what do you think that is? 16 inches. When a wheel turns once, it covers a certain linear distance. Exactly pi times 16. Oh, there's that beautiful number again. That's the whole point of 3.14. It's how far a wheel will go if it turns one time. You take a diameter, 16 times 3.14, that's how much distance it covers. So that's about, what's that, 48 feet, 48 inches, 50 inches or so. Well, if you put bigger tires on your car, you're going to cover more distance, aren't you? If you put a 17-inch tire versus a 16-inch tire, you're going to pick up an extra 3 or 4 inches per rotation. Well, the speedometer assumes you have 16-inch tires on your car. It's counting the number of rotations you're making, and it's sticking that out as a speedometer. Well, it's telling you as if you had 16-inch tires on your car. If you have larger tires on your car, you're actually traveling more distance in the same time, thereby making you go faster. And the thing is that over a mile, that's a lot. You're picking up 4 inches here, 4 inches here, 4 inches here, 4 inches here. That accumulates. And it adds up to 5, 6, 7 miles an hour faster than your speedometer is indicating, close to the speed limit of 55, 60 miles an hour. That's a problem. A couple of you guys were nodding, yes, that's happened to me. Now, has it gone that way for you guys where you're going fast, you have larger tires on? It happened for a while. Back in the early 90s, there was all the rage to put these little tiny tires on people's cars too. I don't understand that one. But that was working the other way. In that case, you go from having 16-inch tires to 4. And all of a sudden you're going 12 miles an hour. But the speedometer says you're going 30, 40, 50, but you're actually going 12. So I mean, that is what happens. That is what happens. So that's how your speedometer actually works. But this is how the police give you speeding tickets. They point that radar gun at you, and it goes. And what are those? What are those? 2 points on the curve, time-wise. And in those 2 points, you have traveled a distance. They have your slope now, don't they? You've traveled a certain distance over a certain time. You've traveled a certain distance over a certain time. Out comes your speed. That's all it is. Distance over time. That's all it is. And as those time increments get very, very close together, you get closer and closer to your true speed. You're actually you're doing an average speed if you think about it. You're actually doing an average speed. Or they're doing an average speed. But it's so close to, and I don't know, I mean, I haven't contested a speeding ticket in 20 years. I'm sure the precision's gotten better over 20 years. Lord only knows. I bet you 1,000th of a second is probably pretty close to what that radar gun is doing. Pretty crazy, huh? Pretty crazy. Plus they have to correct for the I'm sure the gun does this, they have to correct for the angle. Because if you can think about it, you guys were directly next to me when I came by you. But the policemen generally are kind of off at an angle from you. Now sometimes you're coming straight towards them-ish. But if they're back off the road, say 40 feet, like in the bushes hiding, now the gun's no longer pointing straight back at you, it's coming at an angle. So that, I'm assuming that's one more setting they have to put on the gun to account for trigonometrically. But you guys could handle that too, based on what you did in question number 2 on your exam. Don't want to brag, but you have that skill now too. So how fast was I going? Well, how many feet per second? How many feet per second? Let's turn this
On the
on.
last question?
Yeah, give me the last one. 30.
36.79 feet per
Okay. We're going to go ahead and let Google do the conversion. 36.79 feet per second, 2 miles per hour. 25 miles per hour, just about. That's how fast I was going when I came across that 200-foot mark. Not bad. Who guessed 25? Somebody guessed 25. Didn't they? I think somebody did. Was it Ian? I'll give him credit because he's not here. I'm pretty sure it was him, actually. So about 28, but 25 miles an hour. There you go. By the way, FYI, the conversion I just did using Google, and I even spelled it wrong, and Google still read my mind, to aper. In your project due Wednesday, I tell you to go back and check your work using Google. This is one of the most phenomenal, and again, this is a little bit just dating myself here, but back in the day, Google wouldn't do conversions. You had to use online converters, and there are online converters. If you type in convert to Google, the first hit is onlineconverter.com, which I used for years and years and years. But Google has gotten so good. Google can do mathematics in its search bar. I have you do that in your project too. Convert 10 to the -7th millimeters to feet. It can do all kinds of wonderful things. Please use that to your advantage. Remember the problem, if you haven't looked at the project yet,
Type it in right.
you have to, well, sometimes it can read your mind.
Yeah.
There are some conversions it can't do. If you get too crazy with the units, it'll fart out and say, I can't do it. But that's okay, because you can do part of it on paper and then the rest of it in Google. The conversion I have you guys do on the project, the tadpole pond problem, if you fill an Nalgene bottle in 2.2 seconds, what size pond pump would you need? You can type that directly into Google and it'll do the math for you there too.
The problems in Google. Like the whole, someone has actually typed the entire problem.
It's finding my document, I bet.
Probably.
It's fine. It's because my document is posted because Google's genius.
Yeah.
Because
It's
Google's.
almost word for word.
Well, it's somebody's. It's just. It's. What I'm guessing is it's finding. There you go. Thank you. Hang on.
You're a good answer.
Wait a minute.
It's almost word for
It's got to be finding my problem, though, right?
I think it
Is it
might be.
gluten-free?
Because it was
Yes.
word for word.
Hang on. Because I've noticed this will happen if things get hit enough.
Yeah, they're pretty good actually.
This guy right here.
Yeah.
Let's just do that. Here's the answer, 400 gallons per hour. FYI, just got that thing running this weekend. Looks totally sharp. Yeah, see, there it is. That's my link.
Yeah. Okay, yeah.
So that's why it finds it. And there's my link again. See my little name? That's yeah, everything else is, yeah. So that I would hope it would find it immediately. So that doesn't give you any update. It doesn't give you any more information, although you can always use Google to find more, help, other resources. I mean, because I'm me, and I make up these problems, like over the weekend I took Max to the sporting goods store, we bought a bunch of balls that we're going to drop and look for modeling data, stuff like that. Because I'm making these problems up, you're not going to find the exact problems online. But look for similar ones, for sure. Look for similar ones. I mean, there are definitely similar conversion problems out there. And use Google by itself as a standalone for that as well. Good? Fair-ish? We happy? 25 miles an hour? Not bad? It didn't feel like I was going 25. That's actually a lot faster than I thought I was going. I thought I was going more like 15 or 16. So, but it's different, Will, than the original 13.3 miles an hour. It's twice as fast-ish. Twice as fast.